Hello everyone, this is Yaoyu from class EL6303. In this video, I will solve the question 1 in homework 3. First, let's look at several general cases, which is the sum of p to the power of k from k equals to 0 to the infinity, and this equation equals to 1 over 1 minus p. This is the sum of a geometric series. Then I differentiate both sides with respect to p. The left side will become the sum of k times p to the power of k minus 1 from k equals to 0 to the infinity, and the right side become 1 divided by 1 minus p to the power of 2, and then I will multiply p to the both sides. The equation will be like this: the sum of k times p to the power of k from k equals to 0 to the infinity equals to p divided by 1 minus p to the power of 2. If I continue to differentiate both sides, this equation with respect to p, I will get the sum of k squared times p to the power of k minus 1 from k equals to 1 to the infinity equals to 1 plus p divided by 1 minus p to the power of 3. And then if I multiply p to the both sides, again I will get the sum of k squared times p to the power of k from k equals to 1 to the infinity equals to 1 plus p times p divided by 1 minus p to the power of 3. Right now, if I can also conduct a differentiation with respect to p to the both sides, then I will get the sum of p to the power of 3 times p to the power of k minus 1 from k equals to 1 to the infinity equals to p squared plus 4 times p plus 1 divided by 1 minus p to the power of 4. Now I have 4 general equations to solve this problem. For part A, we need to find the value of b. Actually, we already know the fact that this math function, the sum of the probability of x equals to 1 from k equals to 1 to the infinity equal to 1. So we just use the first formula, then I can get the sum of b times k times p to the power of k minus 1 equals to 1. Then I plug the second formula into this equation. I can get b equals to 1 minus p to the power of 2. For the second part, I need to figure out the expectation of x. According to the formula of expectation of x equals to the sum of k times the probability of x equals to k from k equals to 1 to the infinity. Now get. Then I plug the value of b and the third equation into this formula. I can get 1 plus p divided by 1 minus p to the power of 3. This is the answer of part B. For question C, I need to find the value of expectation of x squared. Based on the definition of the expectation of x squared, it should be the sum of k squared times the probability of x equals to k from k equals to 1 to the infinity. Now we got b times the sum of k to the power of 3 times p to the power of k minus 1 from k equals to 1 to the infinity. Then I plug the fourth equation into this formula. I will get p squared plus 4 times p plus 1 over 1 minus p to the power of 2. This is the answer of question C. For question D, to find the value of expectation of x squared minus the square of the expectation of x, we just need to plug the answer of part B and C into it. Then I can get 2 times p divided by 1 minus 2 times p plus p squared. This is the answer for the part D. Now let's look at the last part. To find the probability that x equals to k given by x ranging from 2 to 5. According to the conditional probability, I will have the probability that x equals to k when x is more than 2, less than 5, divided by the probability that x is ranging from 2 to 5. And it should roughly equals to 0.83 times k times 1/3 to the power of k minus 1. And here k equals to 2, 3, 4, 5. This is the final answer of part E. Thank you.